Hey, good morning. It's Monday. We're going to start some trig ratios here today, continuing our work with just geometry stuff, Pythagorean theorem, triangles. Before we started that, though, I wanted to go over a couple questions as we start to prepare for the final. This was a paper that you would be getting back today, or if you turned it in on Friday. I graded it, and some people are kind of struggling with some of these problems, and so it's really a good idea to see which ones you missed and why. Some of us missed number 26, and this one here is they just said, here's a pair of ordered pairs. We want to try several things. They said put, instead of a 4-3 right here, we're going to put a 4-5. And so would it still be a function? Well, as I look at my x's, they're all only one time listed there. So we're looking for one that would make it no longer one. If I took the negative 2, 3, which is up there, and I put negative 2, negative 5, well, we still have a negative 2 in the x column. So I don't care about the y's. So that would still be a function. If I took the 6, 4, and I put in a 7, 3, I still look here. I still have all the x's are one time and one time only. I took out the 6, 4 and put in a 2, 5 now. I want to switch pens here. If I put in a 2, 5, well, then I have a 2 here and a 2 here, so that would make it not a function. So it's just kind of putting the numbers in. Here's the equation here. They even gave us the equation. They says, which of the following statements would be solved if we solve for b? Well, it can't be that one because they said solve for b. And so if I did solve for b, you should have a little bit of work over here. I would subtract 4 c's. So then I'd have 2b equals minus 4c plus 8 divided by 2. And I got b equals negative 2c plus 4. So you got to do some work. Okay, a lot of the papers I seen coming in, just, I don't know if you're doing mental math or whatever, but when it comes to this test, I don't know that I would just go with the mental math. This guy here, they said which one best represents the scatter plot. Well, when you do a scatter plot, we kind of have a trend here, and the trend goes like this, and so our line, we want to kind of make it go right up through the middle. We have just as many dots on the top as the bottom. So this one's not a requirement of work being shown because we're just looking for a line that goes right up the middle of the data there. All right, I did want to talk about this one though, because this is what we recently worked on. This is a rate of change problem, and they're talking about that rate of change. Well, this rate of change is a linear equation, and so rate of change is similar to slope. So that one's a minus 2 over 1. If I look at this one, I see that we are going up by 2, going up by 2, going up by 2, and here we're going down by 3, down by 3, down by 3. So this is a linear equation. So if I want to find the rate of change, all I'm going to do is find my slope. I want to use two coordinates. I want to use minus 4. Well, let's use 0, 2. Let's keep it easy. 0, 2, then 2, negative 1. You can use any one of these because the rate of change is the same on all of these. It's a linear equation. So I got minus 1 minus 2 over 2 minus 0. So that's minus 3 over 2. So here my slope is a minus 1.5. So if I look at my slope here I had a minus 2, here I have a minus 1.5, and minus 2 is less than 1.5, so I already like A. On the number scale, minus 2 is more to the left. Okay, so again, don't be skipping these. These are problems that are thinking problems and things that we should know how to do. Okay, all right, let's go to today's now. Here we are. Here's our warm-ups for the day. It's Pythagorean theorem on these and Pythagorean theorem on numbers 4 and 5. So if you'll do those and then kind of just pause your video and come on back, we'll see how you did. All right. So division is when we're comparing two quantities. a ratio. A ratio would be like 1/2, and we have a division sign in there. I got 15 inches for number 2. Number 3, I got B equals, I just called it B, but the missing side is 13.75 inches. Need units. Problem number 4 I got was a right triangle. When I squared everything on the left, it came up to 100. Same thing as 10 squared. And as you can see, the right it's not a right triangle. I got 208 on one side and 400 on the other side. Okay. All right. Now, today we're going to have a whole bunch of trig terms here. Okay. That refer to a triangle. And so when we're looking at triangles now, and it doesn't have to be a right triangle, we already know what the hypotenuse is. That's the longest side. Now, we have 3 angles, obviously, on a triangle. And so let's just go with one of these. But I could draw this angle sign on any one of these corners. And so if I'm just doing the opposite of x, opposite means across from. Very important. Write this on your note. So if I look across from my x angle here, this would be the opposite. Okay. But also, if I had another triangle and I was up here now, in this corner, this would be my opposite. Okay? My hypotenuse is still always the longest side. Okay? Now, a lot of times kids kind of don't put a lot of effort into this adjacent one. Adjacent means next to. But I want to put a note here, not hypotenuse. Because the hypotenuse is a lot of times next to it. So if I'm on this first one here, on x here, and I'm looking across this way, there's my opposite. And so adjacent means next to, so this would be my adjacent. I want the side that's not my hypotenuse that is touching it. So adjacent means I have to also be touching it. So down here on this one, let's just call this angle y. Here's my hypotenuse over here. This one over here would be my adjacent. Okay. These are the 3 ratios that we use for trigonometry functions. And so this one is called sin or sine. Some people say sine. This one's cosine, so the abbreviation on your calculator would be COS, and tangent is TAN on your calculator. These are the trig ratios here, okay, that we're going to be using. Okay. All right. So a lot of times teachers will teach it as this Indian name because it's really neat because it shows the trig ratios that we're doing. So it's called Sohcahtoa. And so the S stands for sine and the OH stands for opposite over H. And so this kind of converts over to our ratios that we're going to have. Ka is the cosine, and what that means is my adjacent over my hypotenuse. So if you go in the letters of the words of the Indian name, not only does it tell you the trig function, but it also tells you the ratio. So then here is TOA would be tangent, and that is opposite over adjacent. These are going to be our trig ratios that we're going to use. Okay. So if you come down here and using those Indian names, if we're standing on angle A, which means right here, and I want to do sine of A, well then sine stands for opposite, which would be this guy over here, little a, over hypotenuse, which would be C. So whatever these numbers are, that's going to be my ratio, opposite over hypotenuse. If I'm standing again on angle A, then I want cosine. Well, that's going to be adjacent, which is my B, over my hypotenuse. And then if I'm going to do tangent, and this one's the one I use the most in construction and things like that. A lot of times tangent is the opposite over my adjacent. Okay, now that's a whole lot to digest there. But once we start playing with these numbers here, it'll all kind of fall into place, so bear with us. All right, so they said we're standing on T. So that's what the capital T means. So I like to come over to my angle here and say, okay, I'm standing right here. And they want to know what the ratio is for sine. So it's opposite over hypotenuse. So if I go to the opposite side, that's going to be a 30 over, and then my hypotenuse, 34. Now you always reduce your fractions. Most of the time we convert it to a decimal. So that's going to be 15/17. Or as a decimal, and usually we go 4 places on this. Let me do this real quick. Sine, so you hit sine on your calculator. No, I'm sorry, that's later. Sorry. You just do 15 divided by 17. Okay, and I'm getting 0.8823. Okay, let's go to cosine. Still standing on angle T, tells me that right there. And up here, cosine adjacent over hypotenuse. Now this is the hypotenuse, and adjacent means touching or next to, so my ratio is going to be a 16 over 34. Again, reduce, which means 8 over 17, or written as a decimal, 0.4706. I believe my calculator's saying my light went off, so I'll have to go turn it on here in a second. Kind of hard to see. And my last one is tangent of T. So I'm still standing on T. Tangent says opposite over adjacent. So that would be the ratio of 30 over my adjacent is 16, which reduces down to 15 over 8. Or in this case, it's going to be 1.875. Okay? So now you got a couple. I'm going to go turn my light on here real quick. Do these guys real quick. We're standing on R. We could stand on any one of these angles here. So we're going to stand on R. So again, we make this little arc saying I'm talking about that angle. All right, pause your video, do those. I want to be right back. I want to go turn my lights on. All right, let's see how you did. Here's the ratios that I got. 8/17. Again, we're going to be using decimals, so may as well just kind of start converting them to decimals. And I got 15/17, 0.8824. And I got 8/15, which is 0.533. All right. Now these are just ratios. Let's go on down here and start using our calculator to find some actual measurements. All right, so this is where you need a scientific calculator. This is a very tiny angle. It's a 5-degree angle here. And they said when I look on this angle here and I go out this way and I go out 1 foot, I want to know how long my hypotenuse is. So what we have to do is we have to figure out which one of these functions are we going to use, sine, cosine, or tangent. And so we got to look at which sides we are working with. We're looking for the opposite, or we have the opposite, and we're looking for the hypotenuse. So which of those ratios deals with the opposite and hypotenuse? Right, sine. So what we do, and this is how we show our work, we say sin 5 degrees equals, what's our ratio? Opposite, which in this case is a 1, over x. All right, let's take our calculator now, and most calculators, you say just hit the sign button, and then you put in 5, and it converts to a decimal. You should be getting a 0.0872. You go 4 digits, and most of the time we do. We go 4 digits. Equals 1x. Okay. I don't know what happens if I hit 5 soon. That says syntax error. So on my calculator, I have to hit sine, then 5, because that's the angle measurement, degrees. And what that really is saying is for every unit that you go out this way, you're going up 0.0872. Okay. So now let's go ahead and finish this. We want the x by itself. Now this one seems kind of productive, but we have to multiply both sides by an x to get this out of the denominator. So now I got 0.872x equals 1, and then we're going to divide it by 0.0872. And don't cheat yourself on these and try to take shortcuts. I'm telling you. 1 divided by 0.0872. I am getting, we're going to round our final answer to the hundredths place. So our x equals 11.47 feet. I know it's feet right here because they gave me the units in the picture. All right. Let's go down and do 3 more. I think yours says you try it here, but I made a mistake on your study guide. Okay, so we'll just do these together because this is one of each kind, I believe. We're standing on angle 8 right here. And what do we have? We have our opposite and we have a hypotenuse. Those are the two. So now again, up here in Sohcahtoa, which one deals with opposite and hypotenuse? Right. So we're going to say sin 8 equals, then our ratio is opposite, which in this case is x, over hypotenuse, 16. Okay, let's convert that 8 degrees to a decimal. I'm getting 0.1392 equals x over 16. Let's get rid of the 16. Should just leave that decimal. Well, no, because we rounded it. 0.1392 times 16. I'm getting, and again, we want to round our final answer maybe to the hundredths place. X equals, unless they tell us otherwise, 2.23, and these are inches. Okay. Here we're standing over here. This is our first one where we're not, it's kind of a different angle. They give, what do we have here? We have these two angles here. We're trying to find this x down here. So we got to figure out again, based on the information they gave us the angle, they gave us the hypotenuse, and we want to find, in reference to this angle here, this is called my adjacent. So what deals with adjacent and hypotenuse? Correct, cosine. So we want to say cosine 38 degrees equals, and my ratio is my adjacent, which is x, over my hypotenuse, 14. Let's get rid of this. Oh, well, let's convert this to a decimal here. So I'm going to do cosine 38. I'm getting 0.7880 equals x over 14. Let's get rid of the 14. I'm getting 11.03 inches. All these are meters this time. Okay. And our very last one, notice they're starting to turn our triangles in different directions, but that's okay. We don't really care. We have a 20-degree angle. And what do we have here? Here's our hypotenuse, because it's always across from the right angle, and not only that, it's the longest side, and we have an adjacent right here. So this is going to be another cosine one. Fooled you a little bit. You thought it was going to be a tangent, huh? 20 degrees. Again, my cosine ratio is up here, adjacent over hypotenuse. So it's going to be my adjacent is, and I like to write these sometimes. If I'm standing here, this is my adjacent. This is my hypot. So it's adjacent over hypotenuse. Let's go now and do cosine 20. Again, you want to do decimal to go to 4 places. 9679397, it looks like. Try it on your calculator. And let's multiply both sides by 28. Final answer. I'm getting 26. I forgot a decimal, sorry. 0.9 397 times 28. I'm getting 26.311, so 26.31. The one stays the same, and now my units, inches. Okay. All right. So now you got a couple to do here. Do these two, pause your video, and then come on back and let's see how we did. All right, here's what I got. I had to use tangent for the first time on the first one. I got 4.79 units. They didn't tell us what our units were here. And then on the second one, they asked us to find two sides on the same triangle there. Even though they gave us just two pieces of information, they gave us the degrees and the hypotenuse, I can find these other two sides here. Okay. You can't use Pythagorean theorem because we need another side in order to do that. So when they give us a measurement of degrees of an angle, we can continue working with our math. Okay. So I got 9.46 for the x, and then over there for the y, I got 7.36. All right, let's go use this. Again, I always encourage on word problems, you've heard a million times this year, always draw a picture. All right, so we have this hot air balloon. He's climbing at a 30-degree angle. So if this is my ground, he's climbing. The wind's kind of pushing him as he's climbing. And he's climbing at 30 degrees. Most of the time we put a little arc like that, and we say how many degrees it is. To the height of 1,000 feet. So that would be this guy over here. To the nearest tenth of a foot. So they're telling me to round it to the tenth of a foot. What was the ground distance? So the ground is down here. Sometimes they could ask how far did the balloon travel to get to 1,000 feet, but they want to know the ground distance, so I'm just going to put an X there. So as I look at my ratios up here, Sohcahtoa, I am looking across here. This is my opposite. This is my hypotenuse. And this is my adjacent. So I have my adjacent and opposite. So what do I have to do with? I have tangent, right? Opposite and adjacent. So again, showing your work, you're going to say I took tangent of 30 degrees. And then my ratio is my opposite, which is 1,000 over the number I want, which is an X. All right, so let's take tangent 30 degrees and make that decimal. Mine comes up with a radical, but I just converted over to decimal. So I'm getting 0.5774. Again, I rounded it. It was a 3.5. 5 pushes the 3 up 1. Okay. Equals 1,000 over x. I need to get the x by itself, so I need to get it out of the denominator first. So basically, I want to take 1,000 now and divide it by 0.5774. So here we go, 1,000 divided by 0.5774. And I am getting 1,731. They said round it to the tenth. 0.9. So, word problem, the ground distance is 1,731.9. And what are our units? Feet. And there's my answer. Okay. All right. You got one now to do. It's kind of very similar, except for now we're going at a 25-degree angle. Okay. The wind must be blowing a little bit harder. And we're going up to 4,000 feet. Holy cow. Getting closer to a mile. 5,280. Pause your video and do this one, and let's see how you did. All right. Let's see how you did. The ground distance the balloon traveled is 8,578.17 feet. Nope, they said round to the nearest tenth here. So let's make that into a 2 here. Oops. All right, 0.2 feet. So more than a mile to get up to 4,000 feet. All right, so today you got to kind of write these tiny. I would encourage you to not only write it as a fraction reduced, but the decimal is really the one that we want here. So maybe we'll just do one real quick. So you need to know your Sohcahtoa up there, so that's kind of nice to write on a paper all the time. So I'm standing on letter A, and so Sohcahtoa says on A, so means opposite over hypotenuse. So my opposite would be a 21 over my hypotenuse, which would be 29. So we'll convert that down to a decimal. It's already reduced. Nothing goes into 21, 29. Now if I'm doing cosine, I want adjacent, which would be 20 over my hypotenuse, which is still 29. So if I did 20 divided by 29, I'm getting 0.6897. Again, rounding it to the fourth place, 10,000th place. And now if I do tangent, tangent means opposite, which is 21 over adjacent, which would be 20. So 21 divided by 20. 1.05. Now, very, very important. Now we're going to go to sin. I want to change my colors here. So we're standing on B, and we're looking this way. So again, sin is opposite over hypotenuse. So I have a 20 over 29. And I'm getting 6897. And if you notice, I have the same ratio here. With my cosine of A is the same as sine of B. So sometimes you can save yourself some work by just looking up there to see what ratio is similar to it. Cosine of B, cosine is adjacent, which is 21, over my hypotenuse, which is 29. And I had that ratio up here for sin of A if I was standing on that, but let's just convert it to a decimal here, which is 0.7241. And now my tangent of B is opposite over adjacent. So there I have a 20 over 21. And if I'm confident about my workup, nope, I don't have it up there. 20 divided by 21, I get 0.9238. All right. So just kind of keeping track of things. All right. We'll see you tomorrow.